Well, hi there. I know it isn't Dinosaur December, but
If there's one thing the history of evolution has taught us, it's that life will not be contained. Life breaks free, it expands to new territories, and it crashes through barriers painfully, maybe even dangerously, but, well, there it is.
so here we are. Because an awesome and absolutely unique dinosaur has recently been described, and I'm fortunate enough to have recently become friends with one of the paleontologists that worked on the specimen, who knows more about it than almost anyone else alive, Ethan Harvey. So I thought I'd have him over so we can learn more about this unusual new Ceratopsian, Lokiceratops, and how it has taught us about Ceratopsian ecology and biodiversity. So thank you so much for coming here today, Ethan.
Yeah, of course.
If you don't mind, would you tell us just a little bit about yourself?
Yeah, absolutely. So I am a field paleontologist. That means I mostly am contributing to the field work, excavation, mounting, preparation, molding, casting, all that more hands-on side of paleontology.
The part that everybody thinks that they are going to do when they become a paleontologist.
In paleontology, exactly. But I still contribute to the academic side, including contributing to research and papers such as Lokiceratops. In fact, if you look in that paper, you actually find me in there. So that's what I do now. I've been at the lab I work for coming up on 3 or 4 years now. I specialize, which means that I focus on Tyrannosaurs. In my work and research, I've chased T-Rex specifically.
This is why we're friends.
To about 3 different states now. I've worked on 3
What's
T-Rexes
the coolest
total.
of all dinosaurs?
T-Rex.
Is it even close?
No,
Okay,
it isn't.
that's correct.
And that's a scientific fact.
See? This is how you know he's an expert.
And but I have worked on a whole array of dinosaurs. In fact, if you look at my arms, these are just my favorites of the specimens I've worked on. And I call this my skin portfolio. And so this is just to show off all the animals I've worked on, and I use it as an educational tool, because if I'm saying I worked on this animal, I get to point at my arm and say, there it is. And but I've worked on tons of things, everything from Pleistocene or Ice Age mammals to Ceratopsians to obviously T-Rex itself. The only thing I'm still waiting on working on is I've never worked on a Dromaeosaur, so a raptor dinosaur. And that I would love to add to the skin portfolio.
Really quickly, do you think there's any chance that Velociraptor could fly? At any stage in its life, powered flight?
The juveniles, powered flight, I'm skeptical of. But I think gliding is definitely a possibility for anything with wings, and the juveniles were definitely light enough where something could have been going on.
I think there's a good chance that they climbed up in trees and bombed down on...
I absolutely think that's completely possible.
Isn't that incredible?
It's awesome. Dinosaurs are so cool.
Yes. Well, okay. So recently you've been working on Lokiceratops. Mm-hmm. Maybe start out with that name.
Yeah, absolutely.
Where did it get that name? And then tell it, like, what is Lokiceratops?
So if we can get a picture of Lokiceratops on the screen here, you'll see that Lokiceratops is a bizarre animal. It's very strange looking. It has the 2 brow horns that have become pretty iconic for the horned dinosaurs in general, but it also has directly on top of the frill these 2, they're called epiparietal horns. Parietals are this big fin at the back of the brain case that's a muscle attachment point for most dinosaurs. If you look at a T-Rex, the very back of the head, you'll see a little heart-shaped bone. That's the parietal. Now on Ceratopsians, like Lokiceratops and Triceratops, that's the bone that eventually became the frill. And so epiparietals literally means on the outside of the parietals. So we get these awesome epiparietal horns like what you see on this model right here. Lokiceratops has some really fascinating ones, including these huge blade-like ones that come off the top.
Yes.
And those reminded our lead researcher on the paper, Mark Lowen, of Loki from Norse mythology and his helmet with the big blade-like horns on it. So that's how Lokiceratops got its name. Now, that's just the first part of the name, because you get genus and then you get species. Now, Lokiceratops rangiformis refers to form of reindeer, because reindeer and caribou are some of the only animals alive today that are asymmetrical, meaning they are not don't have symmetry on both sides. They're not bilateral symmetry, which means if you split us straight down the middle, they're the same on both sides. Humans have bilateral symmetry. Most dinosaurs do. Most animals today do. Reindeer don't, and neither does Lokiceratops.
And reindeer specifically, it's just with the antlers, correct?
Yes, exactly. It is the antlers.
And with Lokiceratops, it's just with the
frill potentially
of
there.
The
now, the horns over the eyes do point in different directions on the skull, We think that's probably plastic deformation from just the compression in the tectonic forces of the rock that Loki
so not
was inside.
not while it was alive.
Most likely not. Now, it's hard to tell some of that for sure, especially with how asymmetric Loki already is, but that is our best guess as to the brow horns. Most of the asymmetry is for sure preserved in that frill of it.
Okay, so it's in these two frill horns, the blade-like horns on top of
That's
the frill,
part
the
of it.
epiparietals.
And so I actually
But
have
there's
some
more?
casts that I can show you with.
Yes.
I've brought casts. These are what's called research casts. Research casts are molded directly just off the real bone without any restoration on it. So these are all molded from the real fossils of Lokiceratops and are only the real fossils of Lokiceratops. They're none of the restoration because we didn't have the whole skull. We had to fill in the missing pieces.
And we only have one specimen of Lokiceratops, correct?
We have one, and that is the one that the entire species was named for.
And that is the one that you worked on.
Yes, that is Loki, and we came to know him as Frederick. So,
Perfect. So is there reason to suspect that it is a male?
no, so in paleontology, when we're talking about so many different specimens, it's the same reason we give them nicknames. Like Sue or Stan the T-Rex have those nicknames because that's easier than saying BHI 1007 or AMNH 5027 or whatever. It's all just easier to say nicknames than those big long codes. So it's more of a common language vernacular instead of anything more complex than that. And so we'll refer to them typically as these nicknames, especially in casual conversation, and also typically that follows with just assigning a gender to the animal. But we really don't know if Loki was male or female.
We do think, though, that there was size dimorphism in Tyrannosaurs, right? Tyrannosaurus rex, anyway.
Potentially. That's a really hot topic. There has been a lot of disagreements. I personally think that we don't have very strong evidence for either way. Because B-Rex is the only T-Rex we have actually successfully sexed. That is more of the gracile morph of T-Rex.
How do you do that?
The medullary tissue inside the femur is preserved. Now, if you do research into medullary tissue, basically what it is when birds, and I believe crocodilians, but you'd know more about that than I would,
So
are undergoing ovulation, getting ready to lay eggs, their femurs actually start to decalcify in order to create the calcium for the eggs. That makes their femurs and their hip bones more plastic, more pliable, stretchy. And we found a T-Rex that had this condition, meaning it was an ovulating female when it died. So it was either pregnant or getting ready to lay eggs. We see that in pretty much every modern species of bird, and we see that in a T-Rex as well. Now that's the more gracile morph, which was always thought to be the males. So we do see kind of two generic groupings, which is the gracile and the robust. However, we also see individuals that are kind of in between. And so I honestly think my current opinion is that T-Rex was an animal that had very high individual variation, which is like humans. Clint, you look different than I do. That's individual variation. Some would say. Yeah. But I'm blonde, you have dark hair. Individual variation. We look different from each other because we're a sexually reproducing organism.
Yes.
T-Rex had a very high variability of that, meaning its degree of individual variation.
As do brown
was
bears
high.
today.
Exactly. In fact, you guys at home could probably tell the difference between two T-Rex specimens just by looking at the skulls.
I know we need to get back to Lokiceratops.
Yeah,
I'm
absolutely.
easily distracted by Tyrannosaurs, and so are you.
I don't blame you.
You recently were telling me a little bit about how we now think Tyrannosaurus rex may have hunted Triceratops and other ceratopsians.
Yes, there is a paper. Now, we're not sure if it was hunting or post-kill autopsy, maybe. But there is an actual scientific theory and hypothesis that a paper has been written on that T-Rex ripped the heads off of Triceratops in order to get to the neck meat. Now, I think we've talked about eventually doing a video on T-Rex in the future.
Yeah,
not
I
to
think
peek behind the curtain. But I honestly, I want to get in depth in that. And I think maybe we save that for that.
Okay.
Because I think that would be a really awesome addition to that video.
I agree 100%. I got to tell you guys, we can get pretty easily distracted talking about how rad T-Rex is. And so the Patreon Extras video for this one is amazing. If you don't already support us on Patreon and you're interested in seeing that video or the host of others that we have, please go check it out. All right, so let's get back to Lokiceratops.
Yes.
If you could kind of explain a little bit more about what it looked like overall? Because, I know with ceratopsians, in general, the basic body is almost identical, just different sizes.
100%. And we get some different proportions in there as well, but it's going to be the same basic body plan every time.
So I'd love to hear...
Especially in the later ceratopsians.
Yes. So I'd love to hear more about, how big it was, which group of ceratopsians it belongs to, and what makes this find so extraordinary.
Okay, absolutely. So, I guess let's start the scenery by talking about its scenery, where it lived and what that environment was like. So it lived in the Judith River Formation, which...
And where's that?
That's in Montana.
Okay.
Now, if you are at all interested in paleontology, you like dinosaurs, you're an advanced level nerd when it comes to dinosaurs, you've probably heard about the Judith River Formation, because a lot of the really popular animals and very important, scientifically at least speaking, dinosaurs have hailed from the Judith River Formation. For example, that's where you get animals like Daspletosaurus, Gorgosaurus. You get a few different raptor species there. Euoplocephalus, that's all Judith River. So we're talking late stage Cretaceous, but not quite to the realm of T-Rex. This is pre-T-Rex. Now, Lokiceratops lived there. Now, we've talked about its predators, but it also coexisted, and this is super interesting, and we'll talk more about this in a bit, with 4 other species of horned dinosaurs. Very similar to
Ceratopsians, right?
All Ceratopsians.
And that's... We used to not think that happened.
No, that biodiversity doesn't really exist today of these 5 different species of megafauna herbivores that are all very similar to each other coexisting. Yep. We don't really see that today.
Because this is like an elephant-sized...
Yeah, so
animal,
Lokiceratops...
So have 5 different elephant species.
The size estimates for Lokiceratops are about 22 feet long and about 5,500 pounds in weight. That puts us in the size range of an Asian elephant. And, that's larger than any rhino today. That's a big animal.
Yeah.
It is the largest of the 5 species that coexist with Lokiceratops. All of them range, some of them get close. For example, Medusaceratops got about 20 feet long, so only a couple feet shorter than Loki.
And some people have hypothesized that Lokiceratops is Medusaceratops. I want you to talk about that at some time.
Yes.
Yeah, if you can talk about that in a little while.
Yeah, absolutely. And we'll get to what makes Loki unique and what makes me and other paleontologists think it is a valid species versus what makes other people think it's not.
Yeah.
But Medusaceratops and Albertoceratops were either in the same formation as Loki or in the adjacent formation, which is a very similar time range and close in proximity but still a different locality, and that's called the Two Medicine Formation.
Okay.
Now, Albertoceratops and Medusaceratops actually make up a new clade within the family of Ceratopsians, and that is, so Lokiceratops is what's called a centrosaurian. There are 2 major families within the Ceratopsian family, right? You get the centrosaurian, like Lokiceratops, and then you get the chasmosaurians, like Triceratops. Okay. And within that, Loki is one of the most derived members, meaning he falls later on the spectrum. Other iconic examples of centrosaurians are going to be animals like Pachyrhinosaurus, if you guys have heard of that, with the battering ram nose. There's also going to be animals like Sinoceratops and Nasutoceratops, which are made famous by Jurassic World. And so Lokiceratops is within that family, but within that family we get a new clade, which is Albertoceratopsinae. And what's super cool about that clade is it is made up by 3 species: Medusaceratops, Albertoceratops, and Lokiceratops. Completely new family, just recently put all together, a subfamily, and just recently described in the same paper that described Lokiceratops. And they are defined by a couple really cool features that make them all look similar, but also you'll notice some differences between them. Yeah. The major one is that they're going to have, we talked about epiparietals, which are the horns on the outskirts of the frill, and Loki and all of the other members of this group will have the big blade-like ones that come off the top. Okay.
Diabloceratops has some...
It has big horns, but they're rounded. They're conical.
Oh, okay.
So it doesn't fit within this group.
Blade-like.
Yeah, blade-like.
So you mean
flat,
like a flattened...
Yep, flat and blade-like.
That makes sense.
And typically curving down is what we see.
Do you know why?
Yeah. Most likely a display feature.
For attracting mates?
Attracting mates or something else. odds are that just because I don't see much purpose for defense in that, besides looking bigger maybe. And as many things in evolution, things can serve different purposes, and it doesn't have to be for a specific reason. It just has to be useful enough to keep or get bigger, right? And so we do see, for example, this is actually one of Loki's big epiparietal horns. So this is one of those big blade-like horns. You can see how thin it is and how flat it is. And this would be even bigger and most likely pointed at the bottom when it was alive, because this would be covered in keratin, which is what our fingernails are made of, what our hair is made of, and what rhinos' horns are made of. And reptiles have this too. And in fact, crocodiles' entire faces are keratin. And so this would be coated and make this about 30 to 50% longer and most likely sharpened. But you can still see it's very flat and almost blade-like. That is diagnostic to the group. Another diagnostic feature of this group is going to be having 6 or more epiparietal horns, so even just the little triangular ones on the outskirts of the frill. And then there's going to be a lot more kind of complicated things. For example, the central part of the frill right there, it should be in this group rounded instead of flat. It should be, if you cut it in half and look at it from the top, you should see a nice half moon shape instead of a flat shape.
Like cross section.
The cross section, exactly.
Okay.
And so those are all diagnostic features that made this group valid and also let us know a lot more about centrosaurines in general. That's what's so exciting about Loki, is for the first time it allowed us to really reanalyze what makes centrosaurines, especially Mark Lowen and Joe Sertich, which were the primary researchers on this paper. They really did the legwork in reanalyzing what centrosaurs are and how that divides with the chasmosaurs. And that helped us figure that out and shuffle around some species, so now we have a much better idea of what these families look like. So what's really cool about Loki is it actually coexisted with 2 of its closest family members, which is really
unusual.
awesome. It's very unusual.
Because usually we think niche partitioning is going to happen.
Exactly, and we should see, technically, as some sort of difference in feeding mechanisms, whether that be different shaped teeth for processing food differently or different plants in general, but we don't really see that. So something mysterious was going on that allowed them to niche partition. We don't know what. It could be some sort of sexual selection or display or anything along those lines, but point is we don't know for now. We have theories, but it's kind of a mystery. And so we get 5 different horned dinosaurs in the same locality, all coexisting, all similar sizes. Again, Loki was the biggest, but all in this same group and coexisting apparently without any issues.
And so to go back, why do you suspect that Lokiceratops is a unique species?
So there are a couple reasons. Again, if we are going to reassess if Lokiceratops belongs to one of its cousins instead of being its own species, we would look at Albertoceratops and Medusaceratops again. Now, most people, if they regroup Loki, are classifying it under Albertoceratops, because Albertoceratops, we only have a juvenile, and it's a lot more fragmentary. We have several specimens of Medusaceratops. Even if not all of them have been described in science, we have a pretty good idea of how that animal looked. In fact, we know it had like a little weird square nasal horn. Meanwhile,
which this
Loki,
has no nasal horn.
We have our beak right here, and we actually had this process as well. And we don't. And while we don't have exactly where a nasal horn would be, we have leading up to it. And in Medusaceratops and other horned dinosaurs with a nasal horn, you'll see this texture start to get really bumpy and what we call rugose. And that is the texture we see that leads to a nasal horn. On Loki, it's completely flat and smooth. And we see that in other horned dinosaurs that lack a nasal horn. Also, Medusaceratops has a different count of the epiparietals on the outside of the frill, and a lot of them are a different shape. And so already we're starting to see some differences with Medusaceratops. Most people rule that out as the same species. Albertoceratops, on the other hand, a lot more fragmentary, and we only have a juvenile. So what if Lokiceratops is actually the adult of Albertoceratops? I personally don't believe that's the case, because Albertoceratops has, again, a different number of epiparietals, and also the big blade-like ones are actually a different epiparietal than Loki itself. The very most interior one is the big blade-like one on Albertoceratops. Meanwhile, it's second from the interior on Lokiceratops. So that does make a difference right there. Also, again, going back to it, Lokiceratops is asymmetric. We don't see that in Albertoceratops, and the odds of us finding the one mutant asymmetric member of a species, or the one in a million that ends up like that and is mutated and has this really funky thing going on with its frill, is incredibly unlikely. So odds are all of Lokiceratops were asymmetric.
Okay.
That means that it would be a different species than Albertoceratops, which was symmetrical.
Yeah, that was actually a question I've had for a while, is why do you suspect that they were all asymmetrical versus, since you have a sample size of 1?
It's just a likelihood thing, right? I mean, there is a percent of a percent of a percent of a percent of a population at any given time is going to get fossilized. An even smaller percent of a percent of a percent is going to be found by us millions of years later. So the odds of us finding this one unique one that was asymmetric is just, it's so statistically unlikely that it's pretty easy to rule out as a probability. That suggests that just the group is like that as a whole.
Interesting.
Or at least the species.
Yeah. A little off subject, but
No.
Stygimoloch. What is it?
I think it's at the very least, it's a valid species. It might be, Pachycephalosaurus. I don't remember. Wyomingensis is the original.
A different
Stygimoloch-
species of Pachycephalosaurus.
Yeah, it might be a different species of Pachycephalosaurus.
But not a juvenile.
But I am pretty firm that the three species, Dracorex, Pachycephalosaurus, Stygimoloch, are all distinct in some variety. Either that be under the genus Pachycephalosaurus or under their own genera. Up for debate. I personally love the name Stygimoloch and Dracorex, and so I would really like those genera to stay valid, but that's more of a biasy thing. Yeah, I do like that. But that's more of a biasy talking than actual science. I'm not a Pachycephalosaur guy. That's another one of the few animals that I've never worked on, so I would love the chance at some point.
My son Owen, his favorite dinosaur is Stygimoloch. And
You're just trying not to break his heart. I get it.
well, the thing for me is it has much larger horns.
And
So it would have to lose the large horns.
the idea is that the dome grows around the horns as it gets bigger, because it also has a flatter dome than Pachy does.
But then Pachycephalosaur would have these
we've
huge
also-
horns underneath the dome.
Right, and we don't have any evidence for that. Also, we don't really see that in any animals today, a larger hypertrophied display feature
Yeah.
that actually gets reduced as it achieves sexual maturity.
Yeah.
That's super weird. But at the very least, I think it's its own species under Pachycephalosaurus, and I would love for it to be its own generic.
Awesome. Okay, so what else do people need to know about
Loki?
Lokiceratops?
Let's just run down some fun facts about it.
Yeah.
I mean, Loki, for example, really cool feature that I did not know until working on this, is actually another feature that makes one of the features that makes centrosaurians. And this isn't, some chasmosaurians do have this as well, but I believe it's secondarily achieved, meaning that it evolved a second time separately, is that the horns of Lokiceratops are hollow.
That's really interesting. That's the bone core.
This is the bone core. Again, so with horns especially, we expect these horns to be anywhere up to twice as long in the animal when it was alive.
That's something. So this is the bone core
Of a Triceratops.
and
So you can compare, and this is missing the orbit. This is the top of the orbit, or the eye socket. So this is the right side horn of Lokiceratops. This is the top of the eye socket. This is missing that completely.
So it'd be even
So you're
longer.
actually looking at just about that much of compared to Loki's horn on this Triceratops. So this would be about, maybe 20% longer. And you can already see just how much bigger that horn is. And so Loki is huge for a centrosaurian. Chasmosaurians in general got substantially larger. Triceratops and Torosaurus are the two largest species that we know. Potentially there's room for others like Pentaceratops or Eotriceratops, but those are very fragmentary animals, so we don't like to really group those in. But as far as actual well-known documented animals, Triceratops and Torosaurus are by far the largest. Odds are they were pretty similar in size and body mass, but Torosaurus had a much longer skull with these big holes in it that lightened it up, much thinner frill as well. Meanwhile, Triceratops was a little bit more
Was it an
heavily
adult
armored.
Triceratops?
No.
Or vice versa?
I don't believe so. Because we have a very good anagenesis and very good ontogeny of these animals.
Of both.
So ontogeny is the study of how animals grow
And I think
up.
we recently found a juvenile Torosaurus.
We have a juvenile Torosaurus.
Which shows
we have juvenile Triceratops. We have adult Triceratops. We even have Triceratops that we believe are elderly.
Yes.
So we have a good range of ages. Anything's possible in paleontology. I never like to fully rule anything out. That's why I rolled it back when I just said no. But because the truth is we'll never see these animals alive. So it's hard
Not
to
with that
say
attitude.
for certain. No, it's a realistic attitude. But it's hard to say for certain anything. But under all current scientific consensus, I would say it's definitely leaning towards no. But still, you get this awesome horn of Triceratops.
What I wanted to point out is that with like any extant mammals that have horns with bone cores, the bone core makes up a pretty small percentage of the total horn.
Absolutely.
But if you look at the skull of a Triceratops, and you're just seeing the bone cores,
they can
it
get
already
up to
looks
over 3 feet long, almost 4 feet.
So how long do you think they possibly could have been?
On adults, I mean, we're talking anywhere between 6 to 7 feet. Yoshi was a Triceratops specimen found, had huge horns, over 4 feet long. So that could have been a 7-foot-long horn when it was alive. Just huge, gigantic bull horns. Really perfect for stabbing other Triceratops and the unfortunate T-Rex.
Do we ever find the sheaths?
Not on Triceratops. We have found keratin sheaths on stegosaur spikes. We found them on raptor claws.
What are those stegosaur spikes called when they're a complete set?
A complete set of stegosaur spikes is called a thagomizer.
This is huge because I think most people think each spike is a thagomizer.
No, it has to be all 4 in order to be considered a thagomizer. But we found that on those guys. Not Stegosaurus itself. It was a Chinese species that I'm forgetting the name of. And then we have found, I believe it was Sauronitholestes or Archaeoraptor, which are 2 North American dromaeosaurs. We have found the keratin sheath on their claws.
Okay.
On the killing claws specifically. And just by looking at modern reptiles, we have a pretty good estimate of how big a horn or a feature like that can get beyond just the bone core. And the answer is a lot bigger. So
that's so hardcore. You don't even see them depicted that way. You just see them depicted with just the bone cores.
I know. That's how we reconstruct them for a long time. We weren't even sure if dinosaurs had keratin like that until
Yes. How did we figure that out?
By finding sheaths preserved.
Okay, on
just
a few.
like that, yeah. Especially on like the beaks of hadrosaurs, the duck-billed dinosaurs. We found a lot of those. We found claws of carnivores that had the sheath still preserved in the rock. That gave us the idea. Okay, we're underestimating a lot of these features on these animals, and so now it's been translated through the whole group.
That is so cool. So we talked about before how you had a bunch of very similarly sized ceratopsians that potentially used similar resources, all living together, and probably one of the most similar situations that we find to that today are the birds of paradise.
Yeah, the only difference is we're talking about megafauna versus these smaller animals. It's easier to niche partition there.
Exactly, but they don't really. They're still utilizing essentially the same resources. Why they have speciated, and this is sympatric speciation, where they're all in the same place, they're all living very similarly. Speciation has been largely driven by courtship displays and female preferences. And so you end up with these very, the females of the different species of birds of paradise are pretty similar morphologically, but the males, very different, and it's all their secondary sexual characteristics that are associated with attracting females. I think that's what you were getting at with these guys.
So that is most likely why so hypertrophy, and you might have talked about this on the channel, is when a feature or a part of an animal becomes very large or exaggerated. For example, the teeth on a T-Rex, the tail fan of a peacock, the plates of a stegosaurus. Those are hypertrophied features. They're very large and exaggerated. Now Loki's big epiparietal horns on the top of the frill, as opposed to the brow horns, are very hypertrophied. In fact, again, this is the horn over the eyes. This is the horn on top of the frill. Yeah, we're talking, this is a very, these are very prominent features. It might be the first thing you'd notice about this animal. It's so prominent. That was most likely on purpose. Now, display of what kind, we don't know. We don't know if Loki was a male. Again, we don't know if he was a female. We have zero idea. Maybe dinosaurs, maybe this species at least, was different from other modern species, and they were showing off to each other. It was they were both trying to impress the other. It was all just a sexual display one way or another. Maybe this was a warning to predators. Maybe it was both. And so we know that this was most likely not strictly for defense, like defending its own body in predation, as potentially the brow horns or anything else might be used, because I don't see much of a way that you could really stab a predator with these. Especially this
especially
one,
that one
was most likely, so, and we'll get back into the
curving down.
asymmetrical, the asymmetry of the animal, but this one especially was most likely curving back down and potentially even impacting the frill again, a lot like we see in Babirusa's with the tusks coming up and coming back and impacting the skull. Loki may have had that going on. And so especially with this specific epiparietal, you can see it's curving down pretty hard. That would have been not the best actual defense, but it could have played a role in defense in intimidating the predator. If you look big and scary, a predator is going to be less likely to mess with you. And so it could have worked for that, and also showing off to potential mates. And that's our best guess as to why it had this kind of overkill, flashy headgear that we see in a lot of ceratopsians. Obviously, some display feature was driving ceratopsian evolution, even more than potentially predation was, which is, that's saying something, because if you're coexisting with T-Rex, you really want to be careful.
Yes.
But we still get very flashy headgear, so obviously they're showing off to someone. And so Loki was just a really extreme example of that.
So interesting. You said you had a lot of cool facts. Have we gotten through all of them?
I think the only thing I want to talk about is, I just want to talk again about the asymmetry, because not only, I don't think I got into the specifics of it, because not only does Lokiceratops have the big epiparietal horns, and they go different directions. Again, this one goes, so this is how it would be oriented on the skull. And it comes up and curves back down, and you can actually see the grain of the bone. The keratin would have followed that grain, and it's curving this way. So that means it's curling back down. So this one hooks up and then hooks sharply back towards the frill.
So this is where it connects to the skull over here.
Down here, yep. This is the rest of the frill coming down here. And I actually have a good chunk of the frill, and I can show you.
Yeah. Let's articulate
And so
those.
let's articulate them just to show you. So this is the center of the frill right here. This is the big middle horn that comes up, and we'll talk about asymmetry with that in a second.
Do you
This
want
is
me to
the
hold
other
one?
one. Yeah, will you hold this right about there?
Okay.
That is how this animal looked. This is the other big epiparietal, and if you look at the grain, we have about 2/3 of it right here, and already you can see it's going a completely different direction. It's arcing straight off. So this one would have come straight and just gone like this. So this one wouldn't have curved back down like this one does. The shape and orientation is completely different than its sister horn, basically. Now the other interesting thing is the center horn right here. This is the very inside epiparietal. On this side, it's tiny. It's only about that big, and it's projecting really far this way. On this side, it's going straight up and down, and it's huge. It's over twice the size of the other one. So that's just two examples of the asymmetry. Also, we actually have, so these are the holes that make up the central holes in Lokiceratops's frill. But on the outside
Which
of
just
the frill,
make it lighter, correct?
they just lighten up the skull, exactly. And they would have been covered in skin when the animal was alive. But we actually have the outside of Loki's frill, and they have a different number of horns from one side to the other, which is really interesting. We don't see ceratopsians that have that, really. There was one Styracosaurus found, but for the rest of all Styracosaurs, they express symmetry. And we have a lot of Styracosaurs. We have a pretty good population there, so it's more likely that we'd find one that was a little bit mutated and weird. And even that, it didn't have a different number of horns. It just was more like Loki in that the horns were differently oriented and kind of overlapped and crazy. So Loki's super interesting just in its asymmetry. That's something that we don't really see in dinosaurs, and that makes Loki super unique.
That is fascinating. Now, you have some of the coolest casts. That's how you got my attention. You were at the Wasatch Reptile Expo, and we talked for I have no idea how long about all of the cool stuff you had there. I do know that it is possible to get amazing dinosaur casts and things of that nature from you. You have
Yes.
a business that does that. Can you tell us a little bit about that? How
So,
people can find you?
It's called Primordial, We're Utah local, but we actually ship all over the world. And if you are wanting casts of Lokiceratops, including his horns and his frill and all the cool stuff, I actually have those available right now.
That's awesome.
For sale. And it's the first casts made available on retail of Lokiceratops. Very cool. But I have everything from T-Rex to Allosaurus, Stegosaurus, Ceratosaurus, all the cool dinosaurs, and some really niche ones for the really hardcore dinosaur fans that get into the nitty-gritty. I also even have real microfossils, non-scientifically valuable stuff on mounts, hardwood mounts that are custom made for every piece. They come with an info card that I hand illustrate and write all of them for. Really fun, and they're just great scientific displays if you want basically a miniature museum exhibition in your home, or you have a huge dinosaur fan in your life and you're looking for a gift. And you can find those at primordialcustoms.com. If you're looking for more educational content, you can look at T-Rexcellence, REXELLENCE on TikTok. That's where I do a lot more of my educational content.
Super cool. And we also may have some of your stuff available here at Clint's Reptile Room in the near future.
Yes.
So we look forward to that.
Yeah.
Well, I appreciate you being here so much.
I appreciate you having me.
And sharing all this. We have a lot of plans to have Ethan back in the future. I've been wanting to do interviews like this with scientists about their research for some time. So if you'd like to see more videos like this one in the future, please let me know. And if you're into dinosaurs, check out this playlist right here and subscribe so you don't miss this Dinosaur December. As always, like and subscribe, and we hope to see you real soon.
So what I heard was T-Rex was nibbling at and necking
Ceratopsians, correct.
Okay.
T-Rex had a lot of HR complaints back in the Cretaceous.
I need to throw this out there, but if anybody is looking to donate a skeleton of a dinosaur, we would love one here at Clint's Reptile Room.